Okay, here we go. This is part 2 of prime factorization. So prime factorization is us factoring any positive integer greater than 1 and trying to figure out what prime numbers that when we multiply them together, the product of prime numbers makes up the particular number we're looking at. So we already modeled with 12. We could factor 12 into 6 times 2. And then when we look at these two factors, we look and figure out, can we keep factoring that factor? Or if it's a prime number, the branch on the factor tree is dead. So 2 is a prime number, so this branch is dead. It can't go any further. The only factors I could write are 2 times 1. But again, that would be kind of silly because anything times 1 is itself. 6, we can factor into 3 times 2. And then if we look at this part of the tree, these branches are also dead because 3 and 2 are prime numbers. Okay, so we're going to model now. Let's say we start off factoring 12 with 3 and 4. Okay, again, we are going to ask ourselves, is this a prime number? And if it is, the branch of the tree is dead. So if I start with 3, 3 is a prime number. So the branch of this tree is dead. It is dying. It's dead. It can no longer continue living. Okay, however, 4 is not a prime number. It could be factored into 2 times 2. Okay, so now I'm going to ask myself, is this a prime number with both these factors? If it is, the branch of the tree is dead. 2 is a prime number, so this branch is dead. This is 2, so this branch is dead. So now all of my branches are dead. They can no longer go on living. So what this means is the product of these prime numbers that we're left with, and you'll notice in both cases it's the same thing. We have 1, 3, and 2 2s. Okay, 2 times 2 times 3 is equal to 12. When we multiply these 3 prime numbers together, we are going to get 12. I could rewrite this with an exponent. When we have prime factorization, a lot of times we may have a same number over and over and over again being multiplied. So we can use exponents to create a shorthand. So this is equivalent to 2 squared, because it's 2 times 2, times 3 equals 12. Okay, so the prime factorization for 12 is 2 squared times 3. Okay, and we want to make sure we write our numbers from in ascending order, meaning we start with the smallest prime number and then kind of work our way towards the higher numbers. So you may want to write smallest prime to biggest. Okay, so you know that the order that we write our prime factorization, we write the smallest prime numbers first, and then we go from there. Okay, so let's do one more example. This one, depending on how much space you have, you may be able to still do it on this page. If not, you can move on to page 17. That's what I'm going to do. I'm going to flip this over and kind of work on page 17. So we're going to do the problem. Let's do 20. Okay. Let's say we have the number 20. And 20 has multiple factors. So I'm going to set up 2 factor trees because kind of like with 12, it didn't really matter what 2 factors we started with. We ended up with the same set of prime numbers. With 20, it's going to be the same thing. So with 20, we could multiply 4 and 5. So I'm going to draw branches of the tree that say 4 and 5. We could also do 2 and 10. We could also do 20 and 1, but again, that's going to be a little bit pointless because anything times 1 is itself. So now I'm going to look at the branches of my tree and determine if they're a prime number or not. If they are, the branch is dead. So 5 is a prime number, so this branch is dead. If I look over here, 2 is a prime number, so this branch is dead. However, 4 and 10 are not prime numbers, so I'm going to factor them further. 4 can be broken down into 2 times 2. 10 can be broken down into 2 times 5. And it looks like with both of these, the branches are dead because 2 and 5 are prime numbers. So the prime factorization for 20, if I write it from smallest prime number to largest, 2 times 2 times 5, or if I rewrite it with an exponent, 2 squared times 5. That is the prime factorization for 10. And every single number, it's going to be unique. Every single combination will be unique.